Imagine living in a peaceful rural home, surrounded by nature, far from the noise of the city, but with one big challenge. There's no access to a centralized sewage system. So where does your wastewater go? Hi everyone, I am Siti Ayesha Pisalik, and today I'm going to walk you through a system that plays a silent but vital role in sanitation, especially in remote and rural communities. It is called On-Site Sewage Treatment System, or OSST. This system is designed to safely treat and dispose of wastewater right at the source, reducing environmental impact and protecting public health. Let's explore how it works, how it's installed, and why every detail matters. The OSST system is a decentralized wastewater treatment method. Instead of connecting to a city-wide sewer line, wastewater from homes is treated on-site, meaning directly on the property. It uses a combination of natural filtration, like letting water pass through soil, and mechanical processes, such as separation of solids in a septic tank. This method is commonly used in rural areas, remote communities, and places where extending sewer lines would be too costly or impractical. With proper design and installation, OSST systems help prevent environmental pollution and ensure that nearby groundwater sources remain clean. Choosing the right location for an OSST system is very important because poor placement can lead to contamination and system failure. Here are some key considerations. First is drain field space. This is the area where wastewater is filtered by the soil. It needs to be large enough and have soil that drains well, so water doesn't pool or cause backups. The second one is regulatory distances. Local health departments set minimum distances to prevent contamination. For example, the septic tank should be at least 50 feet or 15.2 meters away from water wells. The drain field must be 100 feet or 30.5 meters from wells to allow proper soil filtration. The seepage pit, which is deeper and more prone to leakage, must be 150 feet or 45.7 meters away from any well. The third one is soil percolation rate. This refers to how quickly water can pass through the soil. If the soil drains too slowly, wastewater may back up. If it drains too fast, it might not be filtered properly. For poor percolation, systems like sand filters or elevated mound systems may be used. Now, let's move on to the actual installation process, which involves several important steps. First is excavation. A backhoe is typically used to dig trenches for the septic tank, seepage pit, and drain lines. The depth and slope of the trenches must follow engineering guidelines. The second one is tank placement. The septic tank must be installed on level ground. If the ground is uneven, wastewater might not settle properly, which affects how solids separate from liquids. The third is pipe installation. Pipes must be laid out with the correct slope, typically around 1 to 2% to allow gravity-based flow of wastewater from the house to the tank, and then from the tank to the drain field. The fourth is community systems. In some cases, multiple households share a community OSST system. This setup requires a trench connecting each home to a centralized drain field or treatment area. Planning is essential to avoid overloading the system. The fifth one is final inspection. Before use, the system must be inspected, usually by local health or environmental authorities. They check for leaks, proper installation, and compliance with legal standards. To prevent contamination of drinking water and nearby environments, here are the minimum required distances once again. First, for septic tank to water well, 50 feet or 15.2 meters. Drain field to water well, 100 feet or 30.5 meters. Seepage pit to water well, 150 feet. These setbacks help ensure wastewater has enough time and space to be naturally filtered before it can reach groundwater. When installing an OSST system, it is important to keep the following in mind. First is compliance with local codes. every region may have different laws and standards. Always coordinate with local authorities before designing or installing a system. The second one is soil and water protection. A poorly placed system can lead to pollution of wells, rivers, or nearby soil, posing a serious health risk. The next one is alternative systems. If the natural soil isn't suitable, we can use sand filters or elevated mound systems that improve the treatment process even in challenging soil conditions. Next is system maintenance. Like any system, it needs a regular care. Septic tanks should be pumped every 3 to 5 years and drain fields should be inspected to ensure they aren't clogged or leaking. After that is environmental impact. A well-maintained system protects ecosystems, but if neglected, it can cause blockages, leaks, and even complete system failure, leading to groundwater contamination and expensive repairs. To wrap up, the OSST system is a smart, sustainable solution for wastewater treatment in areas without sewer lines. When installed properly and maintained regularly, it ensures long-term performance, protects health, and supports environmental conservation. Every detail, from location to soil type, from slope to inspection, matters. That's what makes this system both powerful and dependable. At the end of my report, there is also a 20-item assessment. These questions are great for reviewing the most important points we've discussed, like components, distances, and best practices. Thank you so much for your time. I hope this presentation helped you understand how the OSST system works and why it is critical part of engineering utilities, especially in areas where centralized systems aren't available. Once again, I am City Ayesha P. Salik, and that concludes my report about the OSST system. That would be all. Thank you for listening.